Right. Hello, today I'll be working out a problem of two genes in blood types. Um, so in humans, ABO blood type locus is on chromosome 9, while RH is on chromosome 1, so two genes. Um, they give us the dominant relationships between the alleles in the RH locus is where RH negative is recessive to RH positive. So before we work out the problem, we need to know the different alleles for the blood types. So I'm just going to go ahead and write them out. So we know for blood type A, we have two possibilities. We can have a homozygous where we write as big I A, big IA. Or we have a possibility of heterozygous, big IA, small I. So for blood type B, we also have two possibilities of big IB, big IB, heterozygous, big IB, small I. And for blood type O, one possibility is small I, small I. All right, and for the RH factors, we know that RH negative is going to be recessive to RH positive. So we write that as recessive, so two small r's. For negative, positive, two possibilities. We can have big R, big R, big R, small r, because the positive we know is going to be dominant to the recessive of RH negative. Okay, and now we can go ahead and look at the problem again and use the information we have. So they tell us a woman whose blood type is O positive, whose father is B negative, marries a man whose blood type is A negative. So the parents of the man are not known. What are the possible blood types that might be found among their children? So we can just draw out possibilities that they give us. So we know that the woman is O positive. And they don't give us any information for mom, but we know they give us dad is B minus or negative. And this woman, O positive, marries a man who is A negative. So what I like to do, I just like to just write out all the possibilities and figure out with the information they give us what we can find, the information we know. So we know that O is I small, two small i's for the woman, and for the man, he has two possibilities. He can be homozygous for blood type A, or he can be heterozygous. Right? And for dad, same possibility. He can be homozygous or heterozygous. Now, with this information, because the woman has two small i's, and we know that for each allele she has, one has to come from mom, one has to come from dad. So with that information, we know that this is not a possibility, and dad has to be heterozygous. Now, we don't have any information for the man. We don't know mom or dad. So we cannot, so we just give both possibilities for the man. Next thing is we can figure out the Rh alleles. So for Dad, he is negative, and negative is recessive. So we know that he would have to be smaller, smaller. Same thing for the man, smaller, smaller. The woman, she has positive Rh factor, so she would have to have one big R. Now, if we didn't know any information from parents, she could be big R, or big R, small r. Since dominant, she could have either. But since we have information for Dad and he has the recessive gene, we know that she has big R, small r. Okay, right. Next thing we can do is just cross them. So with this information, we can set up a dihybrid cross of our possibilities. Right. So the first possibility is we know the woman can be small I, or is small I, big R, small r. And for one of the possibilities of man, we can cross homozygous, blood type A, negative. So first thing we do is we do a single cross between each gene. So we cross the I's. So for the woman and man, we can just go ahead and cross using information we have. Right, so after we do Punnett square, we have a ratio of 1:1 or 100. All children for the I gene will be blood type A heterozygous. Okay, and then we can go ahead and cross the R's, Rh factor. Okay, so when we do this cross, we have 1/2 can be big R, small r. 1/2 small r, small r. So positive, negative, blood type A. Keep track of the information. Next thing we can do is the dihybrid cross. Now it doesn't matter which one you cross with first, because you'll get the same answer when you cross them. So I'll just take this genotype possibility, cross it between the R's possibility, so 1/2. Oops. 1/2 for positive, 1/2 for negative, and then we just multiply them across for each. So 1 times 1 is 1, 1 times 2, 2. So, and then we just write out the full genotype. And then we do the same for the other one. 1 times 1, 1 times 2. Alright, and then this will be blood type A positive, blood type A negative. So those are the ratios we get if the man is would have for the A if he was homozygous. Okay, and next thing we can do is we can do the cross of the possibility of the man being heterozygous. So we do the same thing, except he would have a small I, given that possibility. So we again cross I's, cross R's. Okay, and then when we cross I's, genotypes, the ratio, excuse me, is we get is heterozygous for blood type A, and we get blood type O. So this is A, this is O. Now, we would cross again ours. I'm not going to cross them because it's the same information. It's going to be the same cross. So again, we have 1/2 for big R, small r for positive, 1/2 small r for negative. And then we go ahead and do the same thing, a dihybrid cross between them. So do the i's, put the ratio in front for A, cross between the r's, and then since we have two possibilities for I, we would write those out. Write the 1/2 for small I, 2 for O. And then we would get the same thing, cross those between the r's. Okay, and then we would do cross between all of them. So for each one, we would get 1 times 1, 1, 2 times 2, 4, and genotype big IA, little I, big R, small r, which is A positive, 1/4 for A, small r, A minus for that genotype, 1/4 for O and big R, small r, and the O positive, 1/4 small I, small r, get O negative. So these are the possibilities of all the genotypes we get for the children would be A positive, we get for both possibilities, A minus also for both, and then for if he was heterozygous, we have a possibility of O positive, O minus. Well, they don't specify these. We would give all these would be the answer because those are all the possibilities. We look back at the question for B. So the first child blood type is O negative. What is the probability that their second child will be blood type A positive? Now, since they give us that one of their children has O negative, it's not possible that he can be homozygous because when we did the I crosses, we didn't have a possibility of O blood type. So with that information, we can just get rid of the first. We know he cannot have that genotype of homozygous of both big I's, A's. He would have to have heterozygous big IA, small I, in order to have the children of O negative. So the probability of the blood type A positive for their children, all we have to do is look at our dihybrid cross and we find A positive, C A positive, 1/4. So our answer would be 1/4.